Okay, so character functions could be very useful if we get into the chapters on sentiment mining or text mining. So because they deal with text or they deal with words. So let's look at a few of the character functions. So this one counts the number of characters of x. So here's x. So this is going to have 3 characters. So I'm sorry, no, the length is 3. There are 3 words, or 3, yeah, we could say words there, so to speak. And this one, this stands for what? In the 3rd position, so it's this. And then if we do n characters, how many characters are there there? There are 5. So it's going to return 5. Okay, so we can try it, I guess. Let's try it. So we define x, and now we ask for how many characters are in the 3rd component of x. We get 5. Okay, next one is get a substring from x. So here's x, and we want a string, but a substring of this. So for example, this one we're going to start at the 2nd character, so that's here, and we're going to end at the 4th character, so that's here. So it gives you B, C, D. Okay, here we do the same thing here, but then we're saying replace that part by this. Now, kind of strange. It only replaces the 3 letters with part of this, I guess. I'm not sure which part, but I guess we could test it out, or you can test it out. You could try just well, let's try it. So let's see what happens here. So it takes the first 3 characters from here. So if I redefine x like this and then do it again like this, though, so yeah, it takes the first characters from here and replaces it with wherever it's supposed to replace them in here, which it's supposed to replace them starting at B and going to D. Okay, the next one is the grep function. So you give it a pattern, and you give it a vector to look into. And let's see an example. So the pattern is A, and we're looking in this vector, and it returns the position where A is located. Now, this is fixed as true. But if fixed is false, then it does regular expressions. Now, regular expressions is a whole long topic that we're not going to cover. I hope we won't need it, or we might need it when we get to sentiment mining. We'll see. But they say here you can look up regular expressions in Wikipedia if you want to learn more about what they do. But they're basically a really great way of searching for stuff and replacing stuff. But here, if we set fixed equal to true, then it's not doing regular expressions. Now we'll do, I think, one regular expression in an example here in a little while, but basically not much. Okay, the next one is here, and this is substitute. So you have a pattern and a place that you want to and what you want to replace it with, and the vector. So here's an example. Now, this example is a little tricky because, let me explain it. So here's the example. Now if I run it, it does that. Now let's explain this. So here's an example of sub. So I'm going to replace the first occurrence of this with this. So this will change. Now I don't know how to get all of them to change. I'm not sure if you can use sub or some other function, but this will only change the first one, like that. So now, so this is not the example they gave in the text, and this looks weird. So I'm looking for /s, and then I'm going to replace that with a dot, but there is no /s here, so nothing will be replaced, and I'll just get that. So if you remember, the backslash here is treated as an escape character, and so it's saying treat S as a special character, like maybe it has a special meaning, but there is no special meaning for S, so it doesn't know what I'm talking about. However, there is a special meaning for /s, not S by itself, but /s has a special meaning. But I can't just write /s because, as you see, it gives an error. I have to use an escape character for the /s. So I have to do it like this. I don't know if that makes sense, but I have to do it like this. So now this says that look at this in a special way. Don't treat it just like as /s. Treat it as look for a special meaning for it. And there is a special meaning for this, and it means space. Any space. So what we're doing is we're looking for the first space. Actually, I don't want this one. Well, I'll fix it. We're looking for the first space, and we're going to replace the first space with a dot. So we'll get that. Okay, now if I did it this way, and I had an extra space in there somewhere, it won't replace the second one. I'm not sure how to get it to replace all of them, but it doesn't do it there. Okay, that's that one, sub. Okay, there's string split, so you take ABC, this string, and there's nothing, there's no space in here. Maybe you can't see it, but there's no space in there. It's just two quotation marks right next to each other. So it's going to split this at each place. So it's going to split it into this. Okay, so that's how this works. Okay, and then the next one is paste. So you can start with X. What's X? Oh, X is just a regular string, and then replace 1 through 3 and no separator. Separator is blank. So it's going to do x1, x2, x3. Remember, this is an example of vector recycling. This is a vector of length 3, so x becomes a character vector with 3 x's in it. So then you get x1, x2, x3, no separation there. If we put the separation of m there, then we get this. You can also do this. Today is, using the paste function. Today is, and then the date function returns this. Today is, and then the date. Uppercase to upper makes this uppercase, and to lower makes this one lowercase. Okay, note that the functions grep, sub, and string split can search for a text string or a regular expression. And regular expressions, he says, look up regular expressions in Wikipedia if you want to learn more about them.